Okay, we're live. Do you guys have the quiz pulled up?
I'm pulling it up right now. How was this week for you, Luke?
How's what?
This lesson.
The what?
This lesson.
Oh, it's good.
I struggled with this lesson a little bit more than the other ones.
Yeah.
So you might be helping me out a little bit.
I'll let you know. I haven't
So
studied
when so I'm saying it's good, I just kind of mean I haven't looked at it yet.
Oh, awesome.
Oh no, we're at the same spot. Sorry, my kids were up throwing up all last night, so I'm like,
Shoot. This is due tonight at midnight?
Yeah.
Mm-hmm.
Okay. Let's start quiz.
Okay. 1 and 2, whatever. Okay, when calculating, which hypothesis involves equality? And I think that's the null hypothesis. Isn't that the null hypothesis?
I believe so. I'm trying to remember from last time I took it. I'm like,
yeah. The null hypothesis will be a statement involving equality. Okay, null hypothesis.
Sounds good.
Okay.
Yeah, sounds good.
All right.
Look at me acting like I know what's up.
We're like, go. Yeah. Oh, I feel so bad. I'm so sorry.
No, I felt,
yeah. I was going to say next time I'll bring snacks, but I guess that's not really
virtually
possible.
You can eat it in front of us.
I'm like, look.
You want some?
I got Texas donuts for all y'all. It's amazing.
Okay.
She said the null.
Yeah, it's the null.
All right. So when computing p-value, which hypothesis do you assume to be true? You assume the... Wait, I know this.
Wait, what number are you on?
I'm on 4. Whoa. I told you I didn't sleep at all last night.
Wait, didn't we already decide on what 3 was?
Yeah, we did.
Yeah,
sorry, I was just not reading that right. I was reading the remember that the p-value, and I was just like, where is she? Okay, sorry.
The p-value is the probability of obtaining the sample statistic at the least as the extreme. The one.
So you're computing for the null hypothesis. You want to are thinking that the null hypothesis is correct, right?
I believe so, especially because I don't remember alternative hypothesis. I remember.
Yeah, when we test hypothesis, we assume the null hypothesis is true.
So suppose the null hypothesis mu is 10. Which of the following response represents the alternative hypothesis to the two-tailed test? Oh, hell. Sorry. I'm an Army brat. I swear sometimes. Sorry. So that one is the HA with the mu and then the slash through the equal sign, right?
Yeah.
That's alternative. You're saying? Yeah, that's what it says here in the reading.
Yeah.
The null and the alternative is the.
I'm pretty proud of myself. I remembered that from my class. I failed. Woo!
And then the left-tailed will be the mu is less than 10. That.
Mu is less than 10?
Yeah.
Okay. Which of the following represents the alternative hypothesis for right-handed test? So yeah, greater than.
Dang, 10. We're doing pretty awesome for knock on wood, but.
Yeah.
We submitted, we get like 3, right? We're like, oh.
Crap, yeah. Okay, remember that we determined the outcome of the hypothesis test by comparing the p-value to the level of significance, or alpha. Use this information to answer the next 2 questions. Which relationship would result in failing to reject the null hypothesis? A p-value
that is less than
alpha?
The little a, yeah. Right?
I think so. Let me check though.
It's less than or greater than the little a. I think if it's equal to or greater than the little a, you accept that, like you
accept the null
you fail.
hypothesis.
Yeah, you don't fail to reject or whatever. Yeah, I think that's right. The relationship between the results in failing to reject the null hypothesis. No, in failing to reject, maybe.
So
my brain's not firing. Maybe it's p-value bigger, because if it's the p-value is.
So the reading says, how do we decide if the p-value was small enough to reject the null hypothesis? We need a way to determine if there's enough evidence to reject the null hypothesis that does not depend on the data. We need a number that can be used to determine if the p-value is small enough to reject the null hypothesis. The number is called the level of significance and is often
that's alpha
by the symbol alpha. Okay, so we will use the same decision rule for all the tests. If p-value is less than a, we reject the null hypothesis.
Oh, so I was
Good
right.
job.
Oh, yay.
So it's the second one. P-value is less than a, right?
Right.
Yeah.
Good
I'm
job.
proud of myself with that one. I'm like,
Nice.
yeah.
Okay, an insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim about was $1,500. They are concerned that the true mean is actually higher than this. Use this information for the next two questions.
Okay, wait, did we do 9 already? I'm confused.
Yeah.
9 is what you said, the one you got right.
I got that on 8.
Oh.
8 would be accepting it then. So 8 would be p-value is greater than a. Failing to reject. Wait, so the reading says if the p-value is less than a, we reject the null hypothesis. So we're rejecting the null hypothesis. So that's 9. So p-value is less than a. So a. So the B, I guess, answer is for 9. Which relationship would result to reject the null hypothesis? Which relationship would reject it? Wait, it's the same question.
Yeah, that's what I'm trying to figure out, what the difference is, because I got really confused. It reads exactly the same, right?
So in failing to reject the null so the first one is saying is failing to reject. So basically accepting the null hypothesis.
Okay, so that's p-value greater than a.
Yeah.
Okay.
Yeah, I was looking at it. I was like, what the heck? Sorry to interrupt you, Alexa.
No, you're good.
Yeah, sorry. I got really confused for a second there.
Yeah, me too. I had no idea what was going on.
I was like, I don't even know. All right. So which one is the alternative hypothesis? So the
alternative.
That one is the normal. So wouldn't it be the claim amount is equal to?
Okay.
Wait. Because the null hypothesis.
Yeah.
Yeah, so it's equal to?
Mm-hmm.
Maybe I should take the homework quiz before I study for this, because I'm on a roll.
I think
I'm really out of it. Don't listen to me. Let's see. And the null hypothesis, are we seeing if it's greater than or equal to the question? Is higher.
We originally set the rates and they believed that the average claim was about 1,500.
Yeah, and they're concerned that the true mean is actually higher. So the null hypothesis wants to know if it's greater than 1,500.
Right.
Okay.
Oh, okay.
I didn't say it.
Yeah, you get that.
Okay, I'm kind of like worried. Do you think that maybe HA is going to not equal 1,500? Oh, never mind. That was stupid.
No, it does. Because HA is what?
The average, right?
Like,
right.
It's what you're basing your hypothesis on. So
Okay.
And
Yeah.
the HO is just like,
I can't
well,
explain it
think
more
it's
than that. I'm
actually
not
gonna
with
be
it.
bigger,
Okay.
smaller.
I'm like, eh.
So the insurance company randomly selects 40 claims and calculates the sample mean of X bar of 1650. Use the information to answer the next 3 questions. The insurance company assumes the distribution of the sample means is normal. Is this a good assumption?
Yeah, because the sample size is large.
We're counting 40 as a large sample size.
Yeah, anything like over, I think 30 is a large sample.
30 is the
Okay.
30
Sample
is the
size.
breakoff point for a large sample size.
And that's the central limit theorem.
Okay.
Yep. They kind of give it away. Which theorem?
Yeah.
Which
You're
of the
like,
following is-
You're like, I don't know. All right, which of the following is the test statistic? That's X bar, isn't it?
I think so, yeah. Dang, you are doing good today.
It's not the capital S, right? The capital S is another way to do standard deviation, right?
No, actually Z is test statistic.
Yeah.
Z?
Let's see. The reading
Okay.
says
When Z is test statistic. X bar is
Okay.
sample mean.
since we know.
That's right. That's right.
Okay. The historical mean of sales received at a grocery store is 150 with a standard deviation of 40. The store manager suspects that the average has decreased. She has set up a hypothesis test with this hypothesis. HO mu equals 150. HO mu is less than 150. She will use the level significance of alpha equals 0.5. She then takes a simple random sample of 360 sales receipts from her store and computes X bar is 144.
And we want the Z score.
Yeah.
The crud.
Did you guys get negative 0.25?
How did you do your math? I'm trying to look for the
So it's the same as a Z score from
Mm-hmm.
like last chapter.
Yeah,
Uh-huh.
you
So
take
it's just the 150 minus 144 over the oh wait, no, I did that wrong.
it's 144 minus 150.
I didn't put the standard deviation right.
144 minus 150.
Yeah.
And the standard deviation is 40, and then you put that over the. Does it tell us how many
It's
stores they did?
36, yeah.
So square root is
36, okay.
36.
Yeah.
Mm-hmm.
So it's just 6. So 40 divided by 6. And then take
So,
that number negative.
I got
6.
negative 0.9.
Yeah, 0.9.
Right.
I got that too.
Yeah. Sorry, I
Yeah.
did that wrong at first.
Around to 3 decimal points. Ooh,
I just put 960.
really? My calculator just says 0.9.
Yeah,
Yeah, mine just says 0.92.
mine says negative 0.960195.
It's weird. So you did
Did
this.
you do 50 before 150 before 44? Because it's supposed to be 44 before 150.
Yeah, I did 44 before 150.
So that gave you a
And
negative
wait.
6. And then 40
Negative
divided
6.
by 6, right? Well, square
No,
root of
40.
30.
Yeah, square root of 36.
which is just 6. So I just did 40 divided by 6, and that gave me 6.66 repeating, and then did negative 6 divided by that 6.66 repeating.
I'll try it again.
I'm confused.
Mm,
Sometimes my calculator likes to round things up too, so I don't know.
Oh, yeah. No, I did it again. It's 0.9. I don't know what I did wrong, though.
Hmm.
So just put 900. Sorry.
That's weird.
Yeah, I'm looking at my stuff, and I did everything the same. I don't know why.
So if we round to the nearest 3 decimals, do we put 0.900
Yeah,
or do we just put 0.9?
0.900.
That's what I thought. Okay.
Okay, so we can use the applet now
Oh,
to
crap.
help find the p-value.
Uh-huh.
All right, and how do we find the p-value again?
Oh,
You put it in the applet.
We shade both areas outside of the bars, right? Well,
Yeah, and then it's the area, or
yeah, so then we take the area, and then we're going to take that area is our p-value.
Out both of them outside the bars. I think it's just one. Isn't it just one?
I thought it was to the right.
Yeah.
Yeah, I mean, so looking at the homework or looking at the reading,
I don't know.
it
I
says
didn't look
in
at the
this,
reading.
yeah, it might be actually just be for that specific case, because it says in this case for a two-sided test for one mean to know.
Oh, that's for a two-tailed test. Is this is just a one-tailed test, right?
Yeah.
So we're
I
just
feel
taking the area of one. It doesn't really matter.
So
So-
it's, yeah, it's gonna be the left side. Because remember
1,
when
8, 4.
yeah.
Because why?
Well, if you go to section 4.3.1, the definition, if you scroll down, you can see that they have like 5 chart things, and it's two-tailed, left-tailed, right-tailed, large p-value, small p-value, whatever. And then
Oh, okay.
yeah.
I
So
see that.
it's 0.184.
What the
Wait,
heck?
so it's a large p-value, right? Because, I mean, looking at that thing, wouldn't you consider that a large p-value? So we'd shade both of them. We'd fail to reject the.
It's the type of test you're conducting. Is it two-tailed or one-tailed? Is the question, not which p-value is it.
Okay, and how can we know if it's two or one-tailed?
If it's equal to 0, like if you're trying to prove if it's equal to 0, or if you're trying to prove that it's not, or something like that. I
Okay,
can't remember. It's something like that.
so then we just got 0.184, right, for the answer?
Hold on, I'm backwards right now.
Because I just put in the z-score into the applet of.
Yeah, I got 0.184 too.
Oh yeah, that is it. Sorry. 0.1, no, 0.1.
So we think it's 0.184.
So I think, what interference would you make?
That just kicked me out.
Really?
Yeah, that was weird.
Is that what that noise was? I heard like a da-da-da, da-da-da. I was like,
No,
what is
I
that?
thought it was your kids playing the piano.
Oh, I don't have a piano.
I don't know what that is then. Yeah, I told my kids.
Oh, the music. Clayton, turn it down, dude. I'm a bad mom, and when they're sick, I let them play video games. Because I'm like, I forgot I have to do this
Yeah,
group quiz
no, I
today.
would be doing
So
the same thing. So, okay. Anyway, so we rejected null hypothesis, right?
I can never remember that. So
So since it's larger than 0.05, we have to reject the null
yes.
hypothesis.
Yes, I forgot what the alpha was. You are right.
Okay, so our conclusion is that
We have
there is
oh, Luke is gone. It hates all of us today.
we have sufficient evidence that the true population mean is less than 150, right? Is Luke gone now? Luke's gone now.
Yep. I forgot what the
Oh,
question
Luke's back.
was.
Sorry, my internet kicks me out all the time.
Okay, no, it's fine. Have you looked at
Yeah.
18 yet, Luke?
18? No, I haven't got 17. What was 17?
Okay, so 17s we're rejecting the null hypothesis.
And why was that?
Our p-value is greater than 0.05.
Okay. Cute. What is your conclusion of the problem?
I think we have sufficient evidence that the true population mean is less than 150.
It's less than 150.
Okay. That sounds good. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
That's type 1, isn't it?
I think so, but I just get really confused about type 1 and type 2. That's definitely something that'll be on my paper when I take the test.
So there's a
Yeah, it's a question they ask you a lot. Like it's on the final.
Oh, really?
okay.
Uh-huh.
Fail to reject. Okay, fail to reject the H0. H0 is
Yeah, that
false.
is type 1. I just looked it up. Okay. So everyone got type 1 for that one, right?
Uh-huh.
Oh yeah, when it's true, null hypothesis is true, reject it. Type 1 error. Yes.
Okay. A researcher, you can read it. That's fine. Sorry.
No, it was good. I was just saying, just to fill in.
Oh, okay. A researcher decided that instead of using a level of significance of alpha equals 0.05, he will use alpha equals 0.01. Which of the following will be true? I don't know. His experiment, I don't know.
I think it's the probability of doing a type 2 error will increase. But
So if
I honestly can't remember. What is it? Let me look at the reading. Let me see what it says. I'm pretty positive it's that one though, but let's be honest here.
so he's going to have his alpha be smaller. Then we just have a question about that. How, or yeah, like on 18. Let me see. So we choose alpha to be a small number so that the probability of committing a type 1 error is low. The most common value for A is 0.05, so this is equal to 1 over 20. So when the null hypothesis is true, there is a 1 in 20 chance that it will be rejected at the 0.05 level of significance. Another common choice for alpha includes 0.01. And, okay, if committing a type 1 error is undesirable, why? Okay, yeah, so maybe it's, I think it might be 2. Because if it says, if committing a type 1 error is undesirable, why can't we let alpha equal 0? Meaning the lower we go, the less chance a type 1 is to occur.
Mm-hmm.
So I assume type 2 then will increase, right?
Mm-hmm.
One goes down, the other one goes up.
I guess, yeah. That makes sense. But how do you calculate the probability of
The probability of committing a type 2 error is the alpha.
But question 21 says if alpha equals 0.05, compute the probability of committing a type 1 error. Is that just 0.05?
I believe so. Let me check. I finally got the reading pulled up. So the type 1 error was committed, assuming is the okay, the alpha is the probability of getting whatever we reject, the true or null hypothesis. We say the type 1 error was committed. What? Sorry.
Yeah, that's a funky question. Yeah.
I always do the reading and then I watch the little videos because they explain like what the reading means, because I always leave the reading like, well, I have no idea. Okay. We do not want to commit a type 1 error. So why do we choose a very small value of A? If we choose the value of A to be small, if we choose the value of A to be so small that we rarely commit a type 1 error,
So a type
what would
1
happen?
error, right?
What would happen to the probability of committing a type 2 error? That's the question of this. Is the value of the probability is very small. The probability of committing a type 2 error will be larger. So I was right. It is the second one. So the smaller the A value, the higher the probability of committing the type 2. But the lower is the lower. Like the lower or the smaller is the lower possibility of committing the type 1.
Yeah, the lower you go, the lower type 1 will increase. The higher you go, the lower type 2 will increase.
Yeah. And question 21 is just 0.05, right?
Is it?
I don't know.
Well, are
let's
we
look at the-
we're done with the quiz now, right? So we can go off live.
Yeah.
Okay.
Here, I'll do that right now.
Okay.